has, and that's with yeah, and we're talking negative decibels actually. So I'm pretty sure minrec dB starts at negative. Yeah, okay, now this is starting to make sense. Yes, now this makes sense. Minrec dB is negative 42. 0 decibels is a value of 1. And we're talking in floating point value, because the maximum value is 1 in our audio world for our audio card. So negative 42 decibels, well, that's pretty soft, but it's not so soft. And what we're saying by noise floor height dB is that the noise floor height will always be 20 decibels under that. So the actual noise floor initially is negative 62. Okay? And then, so we're always adding that negative, or that 20 decibels to whatever this comes out to be. So really this is the noise floor, and this is the threshold that the signal has to pass over. And the reason that this value ends up being useful is because the average, this is an average, this is confusing because there's an average here, but we take this and we average it because we divide by 2. So this side here is not, this is negative 42 minus 20. So this goes to 60, negative 60. This is the actual noise floor. This is negative 60, and this comes out to a very low value. And then we take the average value from this one, the current input. So whatever the current input is, we take the average value. And I'm starting to realize, I mean, we could weight this so that it favors, so that the minrec dB doesn't change so drastically, because this gives equal weighting to the current input value, the current input average, and the entire past average. Yeah. Yes, this is negative. This is a low value, negative whatever. And I gotta take that away. And this is a not so low value. This is probably above the noise floor. So this will probably end up going up. And we convert back to decibels. Then we add the noise floor height. So this keeps going up if the input average keeps going up. Yeah? And it keeps going down if the average is lower. So the noise floor, and usually there will not be constant input. Like, even if I'm doing a speech input, you know, I take breaks. There's periods where I don't talk, and that's when it drops back down. One thing I think we can get away with is not to use any of these amplitude to decibel conversions. I think we can do away with it. Let's go ahead and try that. We can implement this right now. So what I'm going to do is, well, I have this on the left side of my screen, so I can just refer to it, even though you can't see it. Where am I? I thought this was the one. It's not Audacity and it's not Honyaku. I think it's this one, no? No? I think it's this one. Alright. Okay, are you ready? Are you ready to implement our fancy noise gate? Which is actually very simple. Whoa. How did I do that? It's just O? That's a funny feature. Sorry about that. It kind of makes you want to party. Well, you know, it's Thursday night. It's not Friday night. It's not 12, so we've been going at quite a while. I hope the audio's working because I wasn't sure about that. But anyway, you know, I kind of want to check. Nah, if it's bad, all's in vain. But this is a cool part that I want to capture. So let me check. Sounds very quiet. The other one, okay. It's very quiet. Let me turn things up a little bit. I bet the audio was super quiet and I apologize. Now it might be super loud. I really can't check until I see the video. But anyway, this is a pretty exciting part. Let's go ahead and implement it. I could check in Audacity. If I keep talking, yeah, that looks like it's way too loud. Maybe like that. Maybe like that's better. That looks like it's pretty good. Let's just try that. So the noise floor is right now around -24 decibels. And when I turn that off, it's going to be a lot smaller. Oh, I should not monitor. Okay, hopefully that didn't kill the audio. So to do that, that's entirely within Input Manager. We want the H file. Oh. What was that? Yeah. Okay, so we will need these two values. You know what? We are going to need... Yeah, we are going to need decibels. The reason being is that... Yeah. So if this refers to 20 decibels, here to here, when we convert back to actual linear value, will be a different range from here to here, because decibels are on a log scale. Yeah. Which means a little bit more work, but you know, no worries. It's really not that much. We just need an amp to decibel and decibel to amp. Cool. And also here we'll have our stuff like, and I think we're dealing with ints. We're dealing entirely with ints in here. That's another difference. Yeah. Audio sample type is int. So what we need is audio sample type. Can I do that? Yeah. Audio sample type. Min rec db. No. Because that's going to still be a double. And we'll also have one for noise floor height. Is height a good word for that? Noise floor. Just noise floor. It's like the opposite of height, right? Because the min rec dB is here, and the noise floor is like that. Just noise floor. That's not confusing. Noise floor dB. Some people like to do that, but I do not. Or is it the other way around? I don't even know. Alright, so we get these guys, and we can init them the same way. And we can just use the same values for now, like 40. They will, the nice thing is they will naturally just gravitate towards what they should be. This is negative 40, this is 20. Okay. Minimum dB to start onset of recording. Number of dB, amount of dB under the min rec dB value we consider noise floor. Okay. Probably used for the offset. Yeah, just stop recording. That's the easier way to. Yeah. So something like that. And then, okay. I have to do rsutil, because I don't think we have that yet. What is that? Okay, rsutil has some things, but it doesn't have. Do I want a float or a double? Well, I'm just going to copy it from my code here. This is a function that I wrote and I have been using forever. So what was that called? Huh? What happened? Oh, the disk ejected. I hate when it does that. Oh, wait a second. Just a second. I have to plug it back in.